Okay, so this is going to go over what's called the perturbation method for linear programming. So if you watched the last video on degeneracy, basically what we're talking about is, let's just say you have an optimization problem here. So you have your objective function, which is like 2x1 plus 3x2, and then you have a bunch of constraints here, right? If you notice, this constraint here is less than or equal to 0. So that is an indicator, it's not always, but it's an indicator that your um, your simplex table will end up basically looping or cycling, and you'll be stuck in this forever loop of trying to solve your system, but you won't be able to find it. So if there a way around it? Yes, it's called the perturbation method. And really what you do is, and I've already kind of set up this table here, right? And really what you do here is in the right-hand side, we're going to add in a variable. We're going to add in a couple different variables. First one is epsilon1, second one is epsilon2, and there's just a um, little constraint that we have is that epsilon2 is much smaller than epsilon1, and you'll kind of see why later. So anyways, so outside of that, we do the same thing as before. We do our simplex method as before. So we're going to find the smallest number, which happens to be -3. We're going to go down. We can try and divide both right-hand sides by whatever numbers these are. Turns out this one's a negative, so we don't focus on this one at all, but we're going to turn on the 4. So we're going to divide this whole row by 4. Right, it's going to be 5 plus epsilon1 divided by 4 is now going to turn into 1/4. Oops. Trying to fix that a bit. It's going to turn into 1/4. This one's going to turn into 1. 2 divided by 4 is going to turn into 1/2. Cool. Remember, this is going to be our pivot point right here. Cool. So because it's our pivot point, our W1 is going to be leaving, and we're going to be getting x2 in its place. We're going to be getting x2 in its place. First, we're going to have our z line. We're going to have x2, then w2, right? And remember, we want to reduce all this, row reduce all this. So what number times row 1? Make a 0 in this part and 0 in this part. So let's do 3 times row 1 plus row naught. It's going to be the new row naught. And let's do row 1 plus row 2. It's going to be the new row 2. Cool. Okay. So 3 times that. Let's do, let's see if I got a calculator here. I don't want to have to do this. All right. All right. So I have 3 halves minus 2. It's going to give me -1/2. -1/2. That's going to be 3 plus -3. It's going to be 0. 3/4 plus 0 is just going to be 3/4. 0 plus 0 is that. And then we're going to multiply 3 by all this. So this is going to be a 15 plus 3 epsilon 1 quantity divided by 4. Right. Your x2 row doesn't change. It's going to be 1/2, 1, 1/4, 0, 5 plus epsilon 1 quantity divided by 4. Right. All right. So now we're going to add the second one. We're going to half and half. So the 1/2 plus 1 is going to give us 3 halves. 1 plus a -1 is going to be 0. 1/4 plus 0 is going to be 1/4. 0 plus 1 is 1. So here we have this whole thing plus our epsilon 2. So let's have epsilon 2. Sorry, it's going to be hard to read. Plus, it's going to be 5 plus epsilon 1 quantity divided by 4. And we'll make this a lot easier in the next table. Okay, cool. All right, so if we look here, we have still not done yet because we still have we have a negative number here, right? And really what we want is we want to go and find our new pivot, keep going on with the formula. So negative 1/2, we go down, we're going to divide both right-hand sides by these two numbers, right? So let's make a quick thing here. Actually, what was that? It's going to be 5 plus epsilon 1 divided by 4. I'm going to make a quick comment. Let's just do 5 plus epsilon 1 divided by 4. Oops. Terrible. My 4s. This would be 4 multiplied by, what number is this? So we're going to be dividing by 1/2, which means we're going to be multiplying by 2, or 2/1, right? Times 2 equals 5 plus epsilon 1 divided by 2. Okay. What was the second guy? Second guy was epsilon 2 plus 5 epsilon 1. Okay. So we have epsilon 2 plus 5 plus epsilon 1 divided by 4, multiplying this whole thing by 2/3, right? Because we're going to be divided by 3/2, which is just multiplying by 2/3 by 2/3. That's going to equal 2 epsilon 2 divided by 3 plus, it's going to be 5 plus epsilon 1 over 6. Okay, cool. So basically, this is what's going to be on our right-hand side, right? So cool. All right. Now we need to figure out which one of these numbers is actually smaller, right? Because remember, these are on the right-hand side. We need to figure out which one is smaller. So this is where that constraint comes in, that epsilon 2 is much, much smaller than epsilon 1. So here we have 5 plus epsilon 1 divided by 2. We have a 5 plus epsilon 1 divided by 6 here. We know if we divide it by 6, it's going to be a smaller number. So it's going to be this entity right here is a smaller number than this number right here. And we know that epsilon 2 is smaller than epsilon 1. So this is going to be an even smaller number. So a small number plus an even smaller number is going to give us a small number. Therefore, this is going to be the smallest number that we get. So whatever row this is in is going to be our pivot, right? Which means this guy is going to be our pivot, right? So let's rewrite this whole thing. So it's going to be a lot of rewriting. Let's see, negative 1/2, right? Negative 1/2. What was it? 0, 0 through 4, 0. Awful handwriting. Oops. 0 3/4, 0. And it's going to be 15 plus 3 epsilon 1 divided by 4. It's going to be 15 plus 3 epsilon 1 all divided by 4. It's going to be a little harsh, I know. Okay, now what was our variables here? So it's going to be x2, and this one's going to be changing down to x1, right? So x2, x1. x2, x1, right? All right, now what was our thing there? It's going to be 1/2, 1, 1/4, 1/4. Okay, it's going to be 1/2, 1, 1/4, 0, 5 epsilon 1 divided by 3. This is 0, right? 0, yeah. 5 plus epsilon 1 divided by 4, I believe. I have awful 4s, they look like 9s. Keeps doing that for some reason. Okay, So 1 divided by 4. Okay. Okay, let's actually go and try and reduce this out already. So let's multiply both sides by, it's going to be 2/3, right? So it's going to be 1 right there. 1, this can be our pivot. 0 times 2/3 is 0. All right, we got 1/4 times 2/3. I don't want to do that in my head. So 1/4 times 2/3 is 1/6. Right. All right, 1 times 2/3 is just 2/3. Right. Okay, this whole thing multiplied by 2/3. All right, so we have epsilon over 2, 2 epsilon over 2, right? Which is actually just this thing here that we just did. So let's actually go and put let's actually keep that the same color. So remember, we're going to put an arrow here to kind of tell us where this is going. So 2 epsilon 2 over 3 plus 5 plus epsilon 1 divided by 6. Okay, so it's going to be that guy here, this guy here, and I'm going to erase all this other stuff here because we don't really need it anymore. Give us some more room. All right. Okay. Okay. Now that we have that, we have our pivot point here, and we need to get all these other entries here equal to 0. So what we're going to do is, let me make this red, we'll do 1/2 row 2 plus row naught. That'll be the new row naught. Then we'll have row 1 minus 1/2. Row 2 is going to give us the new row 1. Cool. All right, let's make this C. This will still be x2. This will be x1. Cool. All right. So here we have it. We're going to do 1/2 of this plus this, right? So let's start off here. 1/2 minus 1/2 is going to be 0. All right, it's just going to be 0 again. So that's going to be 1/12 plus 3/4, right? Let's do that in the calculator. 1/12 plus 3/4 be 5/6. 5/6. Okay. So 1/2 of 2/3 is going to be 2/6, right? 2/6 is going to be 1/3. 1/3, it's going to be like that. All right, then we'll take 1/2 of the right-hand side right here. So, and then add it to this. That's not going to look fun, but okay, let's do it. All right, tell you what, let's do another page for that guy because that looks ugly. It's all right. Let me make Actually, you know what? So what we could do? Yeah, no, let's actually do that. Okay, let's put this guy here. Okay, so we're gonna have 15 plus 3 epsilon 1 divided by 4. It's gonna be multiplied by 1/2, right? So it's gonna be epsilon 2 over 3 plus, and that's going to be 5 plus epsilon 1 over 12. Right? And this guy should be a 4. Oops, keeps turning into 9. Okay, cool. Well, we know that the bottom row is not going to change. 1, 0, 1/6, 2/3. We have 2 epsilon 2 over 3 plus 5 plus epsilon 1 divided by 6. Right, that's going to be that guy right there. Parentheses around this. Okay, and now we're going to have row 1 minus 1/2 of that. So, okay. 1/2 minus 1/2 is going to be 0. It's going to be 0. Okay, now you have 1/4 minus 1/12 minus 1/12, which is just 1/6. Okay, 0 minus 2/6. 2/6 is just 1/3 minus 1/3. Okay, and then what you have is you have this guy, subtract half of that. Draw this in maybe like a different color, give it more, stand it out more. So we're going to have 5 plus epsilon 1 over 4. Subtract epsilon 2 over 3. Subtract 5 plus epsilon 1 over 12. That's a 12, all right? Okay, so this is sort of really, really hard to see, but basically all of our zero is all positive, and we end up having our basic variables. They're all equal to something here. So the thing is, we're finished with the simplex method, but we still have these epsilons that we kind of need to get rid of. And really what we're doing here is we're really taking an approximation by making epsilon super, super small. So in order to approximate, let's actually make epsilon 1 equal to epsilon 2 equal to 0. Okay, so if we make it equal to 0, we'll actually get what our answer is in general. So we end up getting that, what color? Let's make it green. We end up finding out that if we make our epsilons equal to 0, that part's going to be equal to 0. This term's going to be equal to 0. That's going to be equal to 0. So we get that z. Let's make this over here. This. So z equals something. X1 is going to equal something, and then X2 is going to equal something, right? So what does z equal? Z equals 15 over 4 plus 5/12. So 15 over 4 plus 5/12. What does X1 equal? X1, all right, remember, so the epsilon's turned to 0, 0, 0, 0. So 5/4 minus 5/12. 5/4. Is that right? 5 over 4 minus 5/12. Next 2. All right, this is going to epsilon is going to go to 0. This is going to go to 0, leaving us x1 is just 5/6. Leaving us 5/6. Okay, let's go and solve for this guy now. And because I don't want to do this in my head, let's go and use a calculator for this. It would be 15 over 4 plus 5/12. 25/6. 25/6. All right, we have 5/4 minus 5/12. It's going to be 5/6. Right? So this should be, all right, so x2 is 5/6, x1 is 5/6, and then z is 25 over 6. Right? Excellent. So 2x1 plus 3x2. 2x1 plus 3x2. Let's just see if that works actually. So 2x1 plus 3x2 should equal z, so 2x1, that's going to be 10/6 plus 3x2 is going to be 15/6 equals z. All right, good, they have a common denominator 6, so 10 plus 25, 10 plus 15 is 25, so we get that z is equal to 25/6, which is our answer. And that is how you do the perturbation method. It's a little long, but if you kind of follow along, you can really understand it.